When changing the temperature, we need to keep the concentration the same and keep the size of the marble chips the same, the surface area. So in this case, we're going to use large marble chips, and we're going to use 1 molar hydrochloric acid. We're going to have a look at 4 different temperatures: room temperature, from the fridge, and 2 in the water bath over there. The first thing you need to do is measure out 50 ml of your acid, and then measure the temperature, which in this case, for room temperature, is 19 degrees. The next thing you need to do is measure out 5 grams of your large marble chips, and we're going to see how much gas is produced in 30 seconds, like we did with concentration. So, remove your thermometer. Place your marble chips in, and start the stopwatch straight away. This produces 18 ml of carbon dioxide. The second one I'm going to do is from the fridge. So the same technique, measure out 50 ml. You always have to measure the temperature, not just taking the temperature of the fridge, because it will change between taking it out of the fridge and placing it into the conical flask. So straight away, thermometer in, leave it there for 30 seconds and measure the temperature. The temperature for this one is 8 degrees. The next one is 24 degrees C. Which produced 28 ml. And the final one is 34 degrees C. Which has produced 44 ml. So these are our results. As you can see, as the temperature goes up, the volume of carbon dioxide produced also goes up. So when we go to draw our graph for temperature, we know that we go up to 34 degrees. So along the bottom here, which is my x-axis, I need to go up to 34 degrees. So I could have every large square is 10. So that is my temperature in degrees C. Going up the side, I've got volume produced. In 30 seconds, and that's in ml. And that goes up to 44, so I can have 10, 20, 30, 40, 50. So my first value, 8 degrees C, gave me 7 ml. So I go up to 8 and up to 7. For 19, I go up to 18 ml. For 24 degrees C, I have 28 ml. And for 34 degrees C, I have 44 ml. So you can see, once again, as the temperature goes up, the volume produced in 30 seconds of carbon dioxide also goes up. When we talk about temperature, we talk about the speed and energy of the particles. So if we have a cold reaction, so going at say 10-15 degrees C, the particles are moving around really slowly. Eventually they'll collide, but not all collisions are successful. As you increase the temperature, particles have more energy, they're moving around faster, there are more successful collisions, therefore more reactions per second, which increases the speed of reaction. If we have a look at this, with a low temperature, you can see the particles are moving around really slowly, and they're bouncing off. If they don't have enough energy, no reactions will occur. If we increase the temperature and start again, you will see that eventually some successful collisions will occur. So this took 7.5 seconds to react and produce 10 of our product. If we then increase the temperature further, the particles will move around faster. As you can see here, the faster they move, the quicker they produce your products. So that took 1.84 seconds to produce as many products as it did in the previous one.